I want you to do something for me. I want you to hold your hand in front of your face. Look at it. Spread the fingers. Feel the warmth in the palm. Notice the weight of it, the solidity, the way it catches the light. That hand is going to die. Not metaphorically, physically. The proteins will unravel, the cells will stop, the water will evaporate, the carbon will drift away as gas. And if you are cremated, every single thing about that hand, every atom of skin, every molecule of bone, every trace element and every drop of blood will be scattered across the surface of the earth within a human lifetime. And here is what should keep you awake tonight. Not one atom will be destroyed. Not one. The universe does not permit it. Every atom in that hand will go on to become part of something else, someone else. The carbon in your fingernail could end up in a blade of grass in a field you will never see, eaten by a cow you will never meet, drunk as milk by a child who will never know your name. The water in your blood could fall as rain over the Pacific Ocean next February. The calcium in your knuckle could become the calcium in another human skeleton 3 centuries from now. You are temporary. Your atoms are forever, and the distance between those two facts is the most unsettling idea in all of physics. So let me tell you what actually happens, atom by atom, degree by degree, when a human body meets 1800 degrees Fahrenheit. Because when you truly understand the physics of cremation, you will never look at your own hand the same way again. All right, let's start with something you've seen 1,000 times. A flame, a candle on a birthday cake, a match you strike in the dark, the blue cone under a stovetop. You watch the wax shrink. You watch the paper curl and blacken. You watch the thing turn into smoke, and you feel in your bones that matter is being destroyed. You've seen this since you were a child. It's so ordinary you don't even think about it. You'd never dream of calling it remarkable. Fire eats things. That's the story. But let me tell you something funny. If you showed a cremation to a meticulous accountant from another planet, an alien who counted every atom with obsessive precision, that accountant would faint. They would look at you and say, "That is impossible. 150 pounds went in, 7 pounds came out. Where did you hide the rest? Are you running some kind of scam?" And the alien accountant would be absolutely right to be suspicious. Because from the point of view of the fundamental rules, your eyes are lying to you. Fire looks like deletion. Physics forbids deletion. Here is the rule. Matter does not vanish. The atoms you start with must be the atoms you end with, just rearranged into new combinations. If you seal a system perfectly and weigh it, let something burn inside, then weigh it again, the number is identical. Not close, not approximately, identical, down to the last microgram. The universe keeps the receipts. Now, I should be careful here. At the nuclear level, Einstein showed us that mass can convert to energy, that E equals mc squared, that stars burn by turning matter into light. But that is a different domain entirely. That requires temperatures of millions of degrees, pressures found only in stellar cores. In chemistry, in every fire that has ever burned on this planet, in every cremation that has ever occurred, atoms survive untouched. Iron, copper, gold, nitrogen, sulfur, you name it. Antoine Lavoisier proved this in 1789 and lost his head to the guillotine 5 years later, but his discovery outlived him. The universe doesn't care about politics. If you can't count it, you don't understand it. Cremation says, watch carefully, and then seems to make 95% of a human being vanish into thin air. A 150-pound person enters a cremation chamber 2 to 3 hours later at temperatures between 1400 and 2000 degrees Fahrenheit. What remains weighs between 3 and 7 pounds. Over 95% of what made that person physically present in the world has left the building. That's not a rounding error. If you predicted a building would lose 5% of its mass during renovation and it actually lost 95%, you wouldn't shrug, you'd call the police. So where did it go? Let me show you why this matters beyond curiosity. Imagine a universe where burning truly annihilated matter, where atoms upon cremation simply cease to exist, deleted from the inventory. Every cremation would create a tiny vacuum. Air would rush in violently. Every crematorium would sound like a continuous thunderclap. Over thousands of years, your planet would hemorrhage mass into nothingness. The atmosphere would thin. The oceans would shrink. And here's the strangest part. You couldn't even notice, because the instruments you used to measure mass would also be made of matter, slowly annihilating with every reaction. Your rulers would shrink, your scales would lighten, you'd be measuring a disappearing world with disappearing tools, never suspecting that the baseline itself was evaporating. Life would be impossible, because life itself is a continuous, controlled fire. Respiration is combustion. Your mitochondria are furnaces. Your breath is exhaust. If oxidation destroyed matter, the first organism that learned to breathe would have begun erasing itself with its very first breath. So this one fact, that cremation transforms rather than destroys, is not just a curiosity. It is one of the most foundational principles in all of science. Nothing about you can truly end. It can only change addresses. But cremation doesn't stop there. Let me walk you through what actually happens in those 2 to 3 hours, because each step is stranger than the last. Here's a fact that should bother you more than it probably does. Your body is roughly 60% water by mass. In a 150-pound person, that's 90 pounds of water. 90 pounds. You don't feel like a bag of water. You feel solid, substantial. You knock on your chest and it doesn't slosh. And yet, if I could gently evaporate all the water from your body without damaging anything else, what remained would weigh less than your average golden retriever. You are, quite literally, a water balloon that has learned to walk around and worry about its taxes. In the first 20 minutes of cremation, almost all of that water boils away. 90 pounds of liquid that spent decades arranged in the exact pattern that made you, that held the shape of your cells, that carried the electrical signals of your thoughts, rises as steam through the crematorium chimney. Those water molecules have no memory. The H2O that was your brain is identical, absolutely identical to the H2O in a mud puddle, in a comet, in a dinosaur's blood 66 million years ago. Water molecules don't have serial numbers. The water that was you has no idea it was ever you. Within a week, some of that steam has joined a cloud. Within a month, it has rained down on a continent you've never visited. Within a year, it has been drunk by strangers, sweated out, evaporated, rained again. The water that held the shape of your memories is now holding the shape of someone else's. This isn't poetry. This is the water cycle. This is physics, refusing to let any molecule sit still. Your body is roughly 18% carbon. The backbone of every protein, every strand of DNA, every memory encoded in the synaptic architecture of your brain. In cremation, nearly all of this carbon combines with oxygen to form carbon dioxide, CO2, the same molecule that fizzes in your soda, the same molecule that trees breathe in and you breathe out. You exhale about 2 pounds of CO2 every day while alive. In cremation, your body releases the equivalent of several weeks of breathing all at once. One concentrated exhale, one final breath that lasts 3 hours. Within 48 hours, the carbon atoms that were arranged into your neurons are mixing with the atmosphere. Within a year, they've circled the globe. The carbon that was your memory of your mother's face could be part of a wheat stalk in Ukraine by next harvest, part of a loaf of bread, part of a child who will never know your name. Now what about that 3 to 7 pounds that stays behind? Here is something almost nobody knows. The ashes you receive after cremation are not ash. When you burn wood, you get ash, gray, powdery residue. When you burn paper, fine black crumbling. But what you receive in that urn is not that. It's your bones, bone mineral, calcium phosphate, ground into a sand-like consistency. The soft parts of you, the muscles that moved, the brain that thought, the skin that felt, all of that is left as gases. What remains is the scaffolding, the frame. And here is what I find genuinely beautiful, that calcium did not originate on Earth. Every calcium atom in your bones was forged in the core of a massive star that died before our sun was born. The calcium that held your skeleton rigid is between 4.5 and 13 billion years old. It has been part of asteroids, the primordial dust cloud, Earth's crust, countless other organisms. For a few decades, it was part of you. It was never yours. You were just borrowing it. 3% of your mass is nitrogen, locked in your proteins. It returns to the atmosphere, fixed by bacteria, built into plant proteins within a growing season, eaten by animals, built into new muscles, new thoughts, and the trace elements, Iron from your blood, zinc from your enzymes, copper from your liver, all released, all cycling onward. The iron that carried oxygen through your arteries might one day carry oxygen through someone else's. So here's the charge sheet. 60% becomes water vapor, indistinguishable from all other water in the universe. 18% becomes carbon dioxide, mixed into the global atmosphere within days. 3% becomes nitrogen compounds, ready to re-enter the cycle of life within weeks. The remaining minerals become powder, the ground bones of a borrowed skeleton. Every single atom survives, not one destroyed, not one created. Now here's the question any self-respecting physicist must ask. Is there one explanation for all of this? Or do we need separate explanations for each transformation? This is the beautiful part. There is one explanation, one single underlying mechanism, one trick of nature, and it's hiding in the plainest possible place. You are right now sitting in an atmosphere that is 21% oxygen. Every breath you take fills your lungs with this gas. You need it to survive. But here is the part nobody talks about. Oxygen wants to burn you, and I mean that in the most precise technical sense. The reaction between oxygen and the organic molecules that make up your body is thermodynamically favored. It releases energy, a lot of energy. The products, water and carbon dioxide, are more stable than the reactants. You are a pile of fuel sitting in a tank of oxidizer. From the perspective of thermodynamics, you should burst into flames right now, but you don't. This is the oxygen paradox, and it is one of the strangest facts in all of chemistry. Oxygen is desperate to react with organic matter, thermodynamically eager, energetically hungry, and yet, at room temperature, it mostly refrains. Wood sits in air for centuries. Paper doesn't ignite just because you expose it to atmosphere. Your body doesn't combust while you sleep. Something is holding oxygen back, and the deepest reason for that restraint is quantum mechanics. Here is what's happening at the molecular level. An oxygen molecule, O2, has a very unusual electronic structure. It has two unpaired electrons, and these electrons have their spins aligned in the same direction. Physicists call this a triplet state. Most organic molecules, the ones in your body, have all their electrons paired. For every electron spinning one way, there's a partner spinning the other way. This is called a singlet state. And here's the rule. Reactions between triplet oxygen and singlet organic molecules are quantum mechanically forbidden. Not forbidden in the sense of being illegal. Forbidden in the sense of being suppressed. The transition violates conservation of spin-angular momentum. The electrons cannot rearrange themselves without breaking a fundamental symmetry. This doesn't mean the reaction can't happen. It means the reaction is slow, agonizingly slow. There's an energy barrier, an activation energy, and at room temperature, there isn't enough thermal energy to climb over it. The molecules bounce off each other again and again, unable to react. Oxygen paces back and forth outside the door, wanting in, unable to enter, but add heat, a lot of heat, 1800 degrees Fahrenheit worth of heat, and everything changes. At that temperature, the thermal energy is enough to kick molecules over the barrier. The forbidden transitions become possible. Oxygen finally gets what it has always wanted, and when oxygen gets what it wants, it gets it fast. The reactions release energy, which raises the temperature, which speeds up more reactions. It's a cascade, a runaway. A controlled explosion that lasts 3 hours. This is cremation. This is what fire actually is. This is why you don't burn in your chair, but do burn in a cremation chamber. The difference between living and being cremated is a matter of temperature. Below a certain threshold, oxygen is locked out by quantum mechanics. Above that threshold, the lock breaks, and this single mechanism explains every transformation. Why water leaves as steam. 1800 degrees overwhelms the hydrogen bonds. Why carbon leaves as CO2. Oxygen grabs carbon atoms and forms lower energy bonds. Why bones remain. Calcium phosphate is already fully oxidized, and oxygen has nothing left to take. Every anomaly, every single one, the same explanation. Let me explain this in the simplest possible way. Imagine a massive dance hall filled with people holding hands in complex patterns. Long chains of dancers, loops, networks, everyone connected to everyone else. That's your body. The dancers are atoms. The hand-holding is chemical bonds. The patterns are your molecules. Waiting outside is a very pushy guest. Let's call her Oxygen. She desperately wants in. She wants carbon to hold her hands, forming a 3-person chain called carbon dioxide. She wants hydrogen to hold her hands, forming a 3-person huddle called water. But there's a bouncer at the door. The bouncer is quantum mechanics. Sorry, your electron spins are wrong. You're a triplet. These dancers are singlets. The rules say you don't mix. So Oxygen waits, frustrated, pacing, maybe muttering under her breath. Now someone turns up the heat, way up. The dancers move faster. Bonds strain and break. The bouncer starts sweating. At some critical temperature, the bouncer throws up his hands. Fine, go in. I can't stop you. Oxygen bursts through. Carbon, come with me. Hydrogen, come with me. The old patterns fall apart. New patterns form. The water dancers float up and leave through the vents. Steam. The carbon dioxide dancers float up and leave. Exhaust. But the calcium and phosphorus in the bones, they're already in stable configurations. Oxygen looks at them and shrugs. You're fine. Stay where you are. When the music stops, what's left on the dance floor? Just the bone dancers. Everyone else has left the building. That's cremation. One pushy guest named Oxygen, one overwhelmed bouncer named Quantum, and a dance floor that transforms from a cathedral of complexity into a pile of mineral dust and a room full of invisible gas. Now I want to address something that bothers me. A lot of people, including many who consider themselves scientifically literate, think cremation is destruction. The phrase ashes to ashes, dust to dust suggests an ending, a return to nothingness. This is wrong, not slightly wrong, profoundly wrong. Cremation is not destruction. It is redistribution under strict accounting. It is not the end of your atoms. It is the release of your atoms from the temporary arrangement that called itself you. It is not a reduction. It is an expansion, a scattering, a dispersal across the entire surface of a planet. The atoms that were concentrated in your 150-pound body are dispersed across the entire Earth within a human lifetime. Some within days, some within years, but all of them eventually rejoin the great cycling of matter that has been running for 4.5 billion years. The matter doesn't care. The carbon atom that was part of your memory of your first kiss has no idea it was ever part of anything meaningful. It's just a carbon atom. 6 protons, 6 or 7 neutrons, 6 electrons. It will form bonds with whatever it encounters, following the laws of physics, utterly indifferent to its history. You were a temporary coalition. A brief alliance of atoms, held together by chemical bonds, organized by 4 billion years of evolution, given consciousness by mechanisms we still don't fully understand. And then the alliance dissolved. The atoms went their separate ways. The pattern was you. The atoms were always just passing through. Let me take you through a calculation that should make you profoundly uncomfortable. Consider the last breath of Julius Caesar on the Ides of March, 44 BCE, as Caesar was stabbed on the floor of the Roman Senate. He exhaled one final breath. That breath contained roughly 10 to the power of 22 molecules, 10 billion trillion molecules. How many of those exact molecules are in the breath you just took? You'd think 0. It was over 2,000 years ago. Caesar was in Rome. Those molecules have been mixed and remixed with the entire atmosphere ever since. But let's do the arithmetic. I love this kind of calculation because it seems impossible, and then the numbers tell you otherwise. Earth's atmosphere contains about 10 to the power of 44 molecules. Caesar's breath contained about 10 to the power of 22. Your breath also contains about 10 to the power of 22. The fraction of the atmosphere that was once in his lungs is 10 to the power of 22 divided by 10 to the power of 44, which equals 10 to the power of negative 22. Multiply that by the number of molecules in your breath. 10 to the power of negative 22 times 10 to the power of 22 equals 1 molecule. On average, every breath you take contains 1 molecule that was in Julius Caesar's dying gasp. Now, this assumes perfect atmospheric mixing, which takes roughly 7 to 10 years for global distribution. But Caesar died over 2,000 years ago. The mixing has happened many times over. The estimate, if anything, is conservative. And this applies to every person who has ever lived and died. Your grandmother, cremated 5 years ago. The arithmetic is even more generous. Some of the CO2 from her cremation has already circled the globe. Some has been absorbed by trees. Some has been eaten by animals. Some is in you right now. The water that was her body has rained down on every continent. Some has been drunk by strangers. Some has become part of other people's blood, sweat, tears. We are not isolated. We never were. Cremation is simply the moment when that exchange accelerates from a trickle to a flood. Now, one level deeper, because the oxygen paradox has secrets, and this is where things get genuinely strange. In quantum mechanics, every transition between states must conserve certain quantities: energy, momentum, angular momentum, and spin, angular momentum. When triplet oxygen meets a singlet organic molecule, the total spin of the reactants is mismatched with the total spin of the products. The reaction wants to happen. Thermodynamics is begging for it, but quantum mechanics says the spins don't add up. The transition is forbidden. Forbidden transitions can still occur, but they require special help. Radical intermediates that carry unpaired spins, metal catalysts that absorb or donate spin angular momentum, or brute thermal energy that scrambles spin states through violent molecular collisions. This is the deep reason fire needs ignition. This is the deep reason you don't spontaneously combust. And here's what I find absolutely remarkable. Your own cells exploit this same quantum trick. Your mitochondria use oxygen for respiration, extracting energy from food in a controlled way. But they can't just let oxygen loose on your organic molecules. That would be fire. That would be cremation inside your cells. Instead, they use iron-containing enzymes, cytochrome oxidase and its relatives, to carefully, step by step, coax oxygen through reactions that would otherwise be forbidden. The iron atoms act as spin intermediaries, shepherding the reaction through allowed quantum pathways. Your cells are performing controlled cremation every second, every breath. They're burning your food in the same way a crematorium burns your body, except gently, carefully, one molecule at a time. The universe is economical with its ideas. When it finds a good trick, it uses it everywhere. The same quantum spin rules that protect you from spontaneous combustion are the rules your mitochondria exploit to keep you alive. The same physics that makes fire possible makes respiration possible. The same mechanism that will one day disassemble your body is the mechanism that right now sustains it. You are alive because of a quantum mechanical technicality. You are cremated when enough heat is applied to overwhelm that technicality. The distance between life and ash is a spin flip. Now let me tell you why all of this matters beyond the cremation chamber. Life requires complex molecules, proteins, DNA, lipid membranes, all thermodynamically unstable in the presence of oxygen. Given high enough temperatures, they would all burn. But at room temperature, thanks to the quantum spin barrier, oxidation is slow. Slow enough that complex molecules can persist for decades. Slow enough that organisms can repair damage faster than it accumulates. Slow enough that evolution can build cathedrals of molecular complexity without having them burn down every night. Life exists in a narrow window, temperatures high enough for chemistry to work, low enough that oxygen's quantum restraint holds. Earth sits in that window. If oxygen were a singlet instead of a triplet, it would react far more aggressively with organic matter at room temperature. The delicate molecular architecture that life depends on could never persist long enough to evolve. If the activation barrier were lower, the same catastrophe. If higher, aerobic respiration wouldn't work, and complex multicellular life would never have evolved. The barrier is exactly the right height. High enough to protect, low enough to be overcome when needed. This is the knife's edge, and cremation is what happens when you deliberately step off it. Let me now say something about what a human being actually is, from the perspective of physics. You are a pattern, that's all. Roughly 7 times 10 to the power of 27 atoms, arranged in a specific configuration that took 4 billion years of evolution to design. Those atoms form molecules. The molecules form cells. The cells form tissues. The tissues form you. But the atoms themselves are not special. A carbon atom in your brain is identical to a carbon atom in a lump of coal. It doesn't know it's part of a thought. It has no idea it's participating in consciousness. What makes you you is the arrangement, the pattern, and patterns are fragile. Cremation destroys the pattern. The configuration that gave rise to your memories, your personality, your sense of self is scrambled beyond recovery. The information is overwhelmed by entropy. The atoms remain, everyone, but the pattern is gone. Now, I should be honest with you, some physicists would push back on the word gone. In quantum mechanics, there is a deep principle called unitarity, which suggests that information is never truly destroyed, that the complete quantum state of the universe preserves every detail, forever, encoded in correlations too vast and too scrambled to ever reconstruct. This is an open question, one of the deepest in physics. The black hole information paradox touches on exactly this issue. We don't know the answer yet. But for any purpose that matters to a human being, for any meaning of the word that you or I would recognize, the pattern that was you is beyond all practical recovery. This is what death means from the perspective of physics, not the destruction of matter, the destruction of pattern, not the end of atoms, the end of information that was organized in a particular way. Terrifying because the pattern was you. Beautiful because the atoms go on. The carbon that was your thoughts becomes carbon in trees, in bread, in other people. The water that was your cells becomes rain, becomes the tears of strangers a century from now. You were a temporary eddy in the flow of matter through the universe. For a few decades, atoms were swirled into a pattern that experienced itself as you, and then the eddy dissolved, and the atoms flowed on. Let me tell you about a man who understood this better than anyone, and paid for it with his life. Antoine Laurent Lavoisier was a French chemist, born in 1743. In the 1770s and 1780s, he overturned the reigning theory of fire. Before Lavoisier, the dominant explanation was phlogiston. Flammable materials were thought to contain a mysterious substance that escaped when they burned. Fire was loss. Burning was subtraction. Lavoisier had a different tool. He had a very, very good scale. He weighed things. Before burning and after. In a sealed system, the total mass never changed. When metals rusted, they gained mass, because oxygen from the air was combining with the metal. Burning wasn't subtraction, it was addition. Oxygen was arriving. This was the birth of modern chemistry. The realization that the universe keeps perfect books. On May 8, 1794, during the Reign of Terror, Lavoisier was guillotined. The mathematician Lagrange said, "It took them only an instant to cut off his head, but France may not produce another such head in a century." Lavoisier's head, like all heads, was made of atoms. Those atoms dispersed. Some became part of the soil of Paris. Some became part of the plants that grew in that soil. Some are, by now, part of people walking around Paris today who have no idea they carry fragments of a genius within them. The pattern that was Lavoisier is gone. The atoms continue. They were never his to keep. Let me tell you what I find most extraordinary about all of this. It's not any single fact. Not the water leaving as steam, not the carbon leaving as gas, not the bones remaining as mineral, not the quantum spin rules that protect you from combustion. It's that all of these things come from one source, one mechanism, one trick of nature. Oxygen restrained by quantum mechanics at low temperatures, unleashed by heat at high temperatures, rearranging atoms according to the laws of thermodynamics, while the universe keeps perfect count of every particle. That's it. That's the whole explanation. Everything else is details. And this mechanism connects cremation to the deepest facts about reality, the conservation of mass, the laws of thermodynamics, the quantum structure of electron spins, the energy landscape of chemical bonds, the origin of elements in stellar cores, the conditions for life in the universe. You pull a thread, a simple question like, what happens when a body burns? And it goes all the way down, all the way to the foundations of physics, all the way to the structure of the atom. So the next time you see a crematorium chimney, the next time you hold an urn, the next time you scatter remains over a beloved place, I want you to feel something that has nothing to do with grief. I want you to feel the strangeness, the depth, the weight of what is actually happening at the level of atoms and quantum mechanics and the conservation laws that hold reality together. Because cremation, the simplest and most ancient way of returning a body to the world, is a window into the deepest nature of matter and energy, pattern and chaos, permanence and impermanence. Your atoms are immortal. You are not. And the universe has been recycling its matter for 13.8 billion years, building pattern after pattern, dissolving them, building again. For a few decades, some of those atoms were arranged into you. They will be arranged into other things, other patterns, other eddies in the flow, and someday, some of them will be arranged into beings who look up at the stars and wonder about their origins, never suspecting that parts of them were once parts of you. Now, here's my question for you. and I genuinely want to know what you think. If your atoms will become part of future living things, if carbon from your body will become part of trees and animals and other human beings, is that a form of survival? Or is the loss of the pattern, the arrangement, the specific configuration that made you uniquely you, a complete and final ending? The atoms don't care. They never did. But you do. For now. What do you make of that?